As we begin to take a look here in Chapter 7, you'll notice that we're going to be working with the Pythagorean Theorem. And if you look at Chapter 7, what you'll notice is that we're going to be spending a lot of time here in Chapter 7 on working with right triangles. Okay, that's all Chapter 7 is right triangles. Clearly, hopefully at this point, you know that Pythagorean theorem only works in right triangles, and so that's where we're going to start our discussion. Okay, so by the end of this video, you should be able to use the Pythagorean theorem and its converse, which will allow you to distinguish between right, acute, and obtuse triangles. So first of all, recall what the Pythagorean theorem is. It says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Okay, so in other words, identify your hypotenuse. It's always the side directly across from your right angle. The square of that is equal to the sum of the squares of your legs. Okay. Usually I'll say a squared plus b squared equals c squared. It's not wrong if you say c squared equals a squared plus b squared. As a matter of fact, for our purposes in this lesson, it's more advantageous to think about the Pythagorean theorem like this, and you'll understand why when we get to the converse. So example 1 says find the length of the hypotenuse of the right triangle. So again, it's the hypotenuse. So when you set this thing up, it's c squared equals a squared plus b squared. And then just simplify this thing down. Now here's the issue. A lot of people forget at the very end that they got to take the square root. Okay, so don't forget to take the square root. So we're going to do 7 squared. Of course, my calculator's dead. All right, let's try this again. So I have 24 squared plus 49 equals, take the square root of that, 25. All right, I did all the work on the calculator. As long as I see that initial equation set up, shows me that you understand how to set it up. In part B, the initial setup should be, right, this is your hypotenuse, so 10 squared equals 5 squared plus x squared. This is 100, 25, and x squared, so you subtract your 25. And so what you end up with is x squared equals 75. And then take the square root of both sides. So x equals the square root of 75. And at this stage of the game, you should understand, if I don't tell you to round it, you should leave it as square root 75. But more than that, you should look at that and realize I can break this up. That's 25 and 3. Well, 25 breaks down into 5 and 5, and you have a pair of 5s here. So what you do, you can rewrite this. The 5 comes out in front, and the 3 stays underneath the square root. Okay, and we could talk more about how to simplify that radical in class if we need to. Okay, hopefully you remember how to do that. And then finally, part C here in example 1, right, here's your hypotenuse. So x squared equals 12 squared plus 9 squared. That says x squared equals 144 plus 81. Well, 144 and 81 makes 225. Take the square root of both sides. The square root of 225, pretty sure, is 15. Okay, so again, that's all we're doing here in applying the Pythagorean theorem. Okay, more of an application type problem. Okay, a 6-foot board rests under a doorknob and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So here's your board, right? There's your board. It's resting 5 feet away here. The question is, figure out this height right here. It's a Pythagorean theorem problem. It's a right triangle. More times than not, I would not give you the diagram because it just makes it too easy. So in other words, when you're setting that up, you recognize that this is the hypotenuse, the 6. So you get 6 squared equals x squared plus 5 squared. So this is 36 equals x squared plus 25. Subtract your 25 from both sides. And you get that x squared equals 11. And then you take the square root of both sides. So x equals roughly, it says approximately, so that tells me, if it says approximately, that gives me the go-ahead to plug it into my calculator and get a decimal. So roughly 3.32 feet above the ground. In example 3, it says find the area of the isosceles triangle with side lengths 17, 16, and 17. Okay, or 16, 17, and 17. So, one thing to note here, if it's an isosceles triangle, when you draw in the altitude, it also bisects, right? That's the perpendicular bisector theorem. Okay, it's actually the converse of it. So, I can solve for h here. Right, first thing to note, think big picture. When you see area of triangle, the first thing that should pop in your head is A equals 1/2 base times height. Well, I'm trying to find the area of the whole triangle, so I already know something. I already know what the base is. I know that the base is 16. I got to figure out what the height is, and in order to do that, that's where the Pythagorean theorem comes in. H squared plus 8 squared equals 17 squared. That's h squared plus 64 equals, I don't know, 17 squared off the top of my head. Probably should. I think it's 289. 289. Subtract 64 from both sides. So x squared equals 289 minus 64 is 225. And then we take the square root of both sides. So the height here is 15. X is 15. So now I got to go back to big picture. So it's 1/2 of 16 times 15. Well, half of 16 is 8. And then you have 8 times 15. 8 times 15 is 120. It's area, so it's units squared. Okay, so again, more of an application type problem of the Pythagorean theorem, using it to find the area. Okay, I'm going to let you go ahead and work through part B. It's exactly what we just did. If you have a question on it, obviously bring it to class and we'll go from there. Okay, common Pythagorean triples. All a Pythagorean triple is, they are values that work when you plug them into the Pythagorean theorem. In other words, 3 squared plus 4 squared equals 5 squared. Okay, 5 squared plus 12 squared equals 13 squared. 8 squared plus 15 squared equals 17 squared. 7 squared plus 24 squared equals 25 squared. Now, what you can do is, since we have all of those, any factor of those also works. In other words, multiply all of these by 2. If you multiply these by 2, where do you go? 6, 8, and 10. Multiply them by 3, you get 9, 12, and 15. All right, so, and it works for all of them. I'll be honest, the two big ones, you should know this first one and the second one. You should know 3, 4, 5, and you should also know 5, 12, 13. The other ones are a little bit more obscure. And again, you don't necessarily have to know these Pythagorean triples. You can always just use the Pythagorean theorem, but sometimes they help. Okay, so for example, what you could recognize here is this is actually a 3, 4, 5 Pythagorean triple. So 30, 40, this guy's got to be 50. And so you know that without doing any work whatsoever. It's way more efficient, obviously, if you know the Pythagorean triple, but again, it's not the end of the world. Okay, now we're going to transition from using the Pythagorean theorem to its converse. Okay, and so what the converse does is it allows you to classify the triangle as obtuse, right, or acute. So first of all, understand something. If, okay, so we're looking at this first theorem. If the Pythagorean theorem works, obviously it's got to be a right triangle. The Pythagorean theorem only works in right triangles. Okay. Now, if you use the Pythagorean theorem, but you notice that c squared is less than a squared plus b squared, that means the measure of angle C is smaller than 90, which means it's acute. So really what you need to know is if c squared is less than, it's acute. If c squared is greater than a squared plus b squared, it's obtuse. And that is the converse. That's all you're doing. So it says tell whether the given triangle is right, acute, or obtuse. Use the Pythagorean theorem. The first thing you have to figure out is what side's the longest side. Well, in part A, this is the longest side. So what do? You do 3 square root 13 squared equals, okay, we don't know if it's equal, that's what we're trying to figure out, 6 squared plus 9 squared. All right, and so when I do this, when I simplify this out, I get, let's see here, 9 times 13, this is 117, and then over here I get 36 plus 81, which is 117. They are equal, therefore this thing's got to be a right triangle. In part B, I do the same thing. 29 is the longest side. I do 29 squared equals 24 squared plus 16 squared. And then I just simplify it out. So 29 squared, that's 841. And then the right-hand side, I have 24 squared plus 16 squared, and that equals 832. Well, clearly these are not equal, so I got to replace the equal sign. 841 is greater than. If this is greater than, that makes this thing obtuse. This is why I said for this section it's advantageous to have c squared on the left-hand side instead of the right. Because if c squared is smaller, it's acute. If c squared is bigger, then it's obtuse. So I'm going to leave example 6, parts A and B, for you to kind of work through on your own. Again, if you have any questions from those, bring them to class and we'll make sure we go over those and get your questions answered.